This is the intersection of Spadina and Willcocks, which is an example of one of the intersections with no left turn face. So people along Spadina are not allowed to turn left or do U-turns here. Although southbound, if you want to do a left turn or U-turn, you can actually go around Spadina Circle, which is right there. So you can make a full loop and then come back here and make a right turn if you want to turn into Willcocks, which I don't imagine many people do because it's only a block long, but you could theoretically do that if you wanted to turn left here.
The signal has an LPI on both the main street and the side street. So the side street makes a lot of sense because it's a local street and pretty much all of the traffic is going to be turning onto Spadina, so crossing those crosswalks. But on the main street, there's also an LPI, and for some reason it doesn't give a green light to the streetcars, which are going straight, and since they're streetcars, they're clearly not going to be turning across the path of pedestrians. The signal should be showing green during the LPI, or they should just use a leading through interval instead. The signal also has TSP, which extends the light in green and walk for up to 30 seconds, which is actually doing right now. So as soon as the streetcar enters the intersection, it goes to flashing note walk. Because there's an LPI on the side street, the flashing note walk on the main street ends way too early. The crossing distance is only 11 meters, which is 10 seconds at 1.1 meters per second, although the actual flashing note walk is 11 seconds for some reason. The flashing no walk ends so early that you can start crossing after the light reaches 0 and still make it all the way across before traffic on the side street gets a green light, as I will now demonstrate. There's 3 seconds of amber, 2.5 seconds of all red, and then 5 seconds of LPI before the traffic gets a green light. Given that there's an LPI on the side street and no left turns on the main street, it would make more sense for the flashing note walk to continue through amber and all red so that it can start about 5.5 seconds later. Starting the flashing note walk 5.5 seconds later would also allow streetcars to be detected 5.5 seconds closer to the intersection, reducing the unpredictability in the travel times for streetcars between the detector and the intersection. And actually, regardless of this, based on my observation, it seems like the check-in detector for TSP is put actually a little bit too far away from the intersection anyway. So here's the detector. It's located about 155 meters ahead of the stop line. And in the previous clip, we saw that the travel time was about 27 seconds from here to the stop line. There's actually a near side stop before the stop line, but that previous streetcar didn't stop there. From my observations, the streetcars go around the circle at about 25 to 30 kilometers an hour, but then they slow down to 20 kilometers an hour at this right-hand curve here exiting the circle. With the current signal timing, the target travel time within the TSP detection zone is 31 seconds, because it's a 20-second design extension if you're using a 30-second max, plus 11 seconds of flashing note walk. If we did my proposal with flashing note walk through amber and all red, that would reduce to 25 seconds, which would be 20 seconds design extension again. But now the effective flashing note walk would reduce to 5 seconds, because 5 seconds of the flashing note walk would be between when the streetcar checks out and the start of the transit amber. So let's see how this streetcar's travel time compares to that 31-second travel time that's the target for the current timing. Well, it's not looking good because it took 30 seconds just to get to the stop, and then it has to load passengers. The dwell time on its own ended up being more than 30 seconds. with a total travel time of 64 seconds within the TSP detection zone, which is 33 seconds more than the target. Given that the dwell time on its own was already more than the target, the detector should really be just inside the stop, a few meters in front of the stop line, not 155 meters ahead of the stop line. If the actual TSP travel time is longer than the estimated TSP travel time, it can actually create major issues with the TSP operations. Because a streetcar might request a TSP extension in a situation where it has no chance of getting through. So it extends for the maximum 30 seconds, and the streetcar still gets a red light because it hasn't departed the stop yet. In that situation, the TSP has actually increased the delay to the streetcar by 30 seconds because now the next green light will start 30 seconds later than it would have otherwise. Keep in mind that it's not possible to shorten the side street here because it's already at the minimum pedestrian duration. It is possible to put a delay time on the TSP detector, but it would be better to relocate it to be much closer to the intersection to eliminate the travel time variability from one streetcar to another. And like I mentioned earlier, the transit signal needs to display green during the LPI to eliminate these 5 seconds of pointless delay.